So we have a function here. We want to graph it out. So let's just do our own testing out. The first thing is look, is this an even or an odd function? This is neither. Okay, you can go ahead and check that, but it is neither. Okay, and you of course would want to on the exam check. You'd want to look at f of negative x. You'd want to look at negative f of x. And this guy, and you'll see that none of them are equal to one another. Okay, so we look at that. There's no symmetry involved there. Okay, so the second thing that we need to look at is what about vertical asymptotes or places of discontinuity, and there are none because this is a polynomial. So this is a continuous function. The limiting the end behavior of this really has to deal with this guy right here. So the end behavior of this function will be up this way and down that way. Okay, it's a pretty easy thing to work through. Okay, now what about f prime? Well, the critical points are when 6x squared plus 8 is equal to 0. So here we can solve this guy. So 6x squared is equal to negative 8. And of course, this right here, you can already stop. This has no solution. So it looks as though there are no critical values for that. And you can go ahead and just check using like a graphing utility just to make sure that it looks like there aren't any critical values. Okay. So now what we'll do, there's no place for this. Now let's check concavity. Okay, so f double prime is equal to just 12x. Now this guy is equal to 0 when x is 0. So this is a possible point of inflection. And if we take a look at f triple prime, that's just 12, which means that this is always positive, which means that this guy is actually a point of inflection. So 0, 1 is a point of inflection. Now concavity is negative on the interval, so from negative infinity to 0, the second derivative is negative. So the second derivative is negative, which means we are concave down. And from 0 to infinity, the second derivative is positive. So we are concave up on that interval. We can find the x and y intercepts. The x-intercept, okay, is when y is set to 0, when this guy is set to 0. Okay, so I'll find that one in just a second here. But let's do the y. The y-intercept is found when x is 0, and so that's clearly at 1. That's our point of inflection. So right here, that's our point of inflection. On this side over here, we're concave down, so we must look something like this. And on this side, we're concave up. The x-intercept is not as easy to find. Okay, so our question is when is this guy equal to 0? Now there are formulas out there to try to find this guy right here. And there are also ways that we can use the derivative to find this guy as well. However, we don't really need it to get a general picture of what the graph looks like. Okay, we're just trying to curve sketch. So this right here is good enough. We know again that this is concave down. This side right here is concave up, given by this information right here.